planted along streams and rivers. In an ideal world, these buffers would already exist and Calen and I would not have a job. I guess luckily for us, there are plenty of opportunities along our streams and rivers for reforestation because the majority of the streams in southeastern Pennsylvania and along the East Coast look more like the left photo rather than the right photo. When we talk about buffers, you'll often hear a 35-foot minimum number thrown in there. That is not a number that we're setting or any individual organization is setting. That is part of the definition of a buffer from NRCS. And the maximum width of a buffer, the maximum area that we can plant along a stream bank is a 300-foot width. Depending on who you're asking, some grant funders restricted at 200 feet. But again, for context, we're not just working along in the stream bank or just along the bank. Sometimes we are working out to kind of more of an upland context as well. Before getting to the how-to, we're going to start with some of the whys. Why do we do this work? Why do we spend millions of dollars putting these practices out on the landscape, all of our time and effort working with landowners and thinking through these practices? And it's because if we turn the clocks back a few hundred years before colonial settlement, the entire eastern United States was forested. And all of our freshwater systems evolved under these forested conditions. As you all probably know, we could spend hours talking about the influence and benefits of forests, but when we're looking through the lens of ecosystem ecology and stream ecology, we kind of break it down into these broad buckets. So we look at the shade, the temperature reduction that these trees along the streams bring, all of those millions of leaves covering the stream, keeping that water temperature more consistent and cooler. Think about brook trout. Any of our native fish and macroinvertebrates evolved with cold, clean water, and shade is a big component of that. We've been tracking buffers for Stroud about 30 years now, and we have test plots in our own backyard along White Clay Creek. We're very fortunate to be able to see these benefits realized and track them over time. And we've even seen in winter months, when leaves are not on the trees, the water temperature is more consistent and there's a lot less fluctuation in the forested section versus unforested sections. So those trees are really a structural element that are keeping our ecosystems more consistent. Sustenance, everything that lives in the stream needs to eat, and pretty much all of that food, all of that dissolved organic carbon is coming in some form from the plants along the bank. Some of it is the leaves that are dropped directly into the stream every fall, every season. But actually the majority of that dissolved organic carbon is coming from what we call watershed tea, which is when the water on the landscape infiltrates and runs through the buffer, runs through that duff layer, that organic matter layer at the top of the soil, infiltrates the stream and provides that dissolved organic carbon, which feeds that stream system. So the majority of the food that all of our macroinvertebrates and fish need are pretty much coming from the plants along the bank. So we want to make sure they're native plants and that we have enough food for them. Stability is another big component. Erosion is one of the big things we look at when we talk about impairments to streams. And trees are one of the best ways to get there. Woody roots are in the top 3 feet of soil, and they're really helping to keep that soil together and provide kind of this armored network of roots along the bank and further out, up to 300 feet, keeping the soil in place on the landscape where we want it. Roots are also growing over time, evolving with mycorrhizal fungi and creating those relationships which further glue the soil together. And lastly, space. That 35 to 300 foot buffer is keeping enough space from other activities on the landscape, agriculture, development, highways, swimming pools, you name it, keeping those activities on the landscape further from those stream ecosystems so that when water hits the landscape and runs off, it's running through this vegetative buffer before reaching the stream and hopefully has enough time to infiltrate. When you talk about buffers, a lot of people kind of stop at that filtering benefit, but again, we're looking through the lens of stream ecology, and so we try to incorporate it with the other benefits of buffers. All right, so I'm going to start with the how to build a buffer, and then Calen's going to pick us up on the research that has led to these practices. So when we're working with landowners, we largely don't work on our own property, so every buffer starts with a site visit. And We work for a research institution. Part of our job is to ask questions, and that starts at the site visit. So we're asking about access to the site. Is this actually a viable place where we can access with equipment not only for planting, but site prep beforehand, regular mowings, for interns to get out for maintenance? Is this something that we are comfortable signing up for coming back to year after year? Buffers are not a set it and forget it kind of practice, and so that access piece is really important to keep in mind. If we can't access the site, we might not want to plant it. We're also looking at what's there. So what infrastructure, utilities are nearby. We primarily work with agricultural landscapes, especially out in rural Chester County and Lancaster County. And thankfully, we're working kind of with a clean slate there on pretty rural landscapes, but sometimes you do have infrastructure, roads, houses, so keeping in mind the existing infrastructure on the site, as well as existing vegetation, shade, soil moisture. Do you have black walnut that's on the site that's going to prevent other species from growing? So again, asking a lot of questions. Once we've determined that it's a good site and the landowner has signed on for our program, a simple 3-page landowner agreement, we get into the site prep. Everybody's favorite thing to talk about. So, you know, site prep on the low end of things, the cheaper end of things, easier sites looks like just mowing the grass down to keep it low. The more intensive sites, you know, if we have a lot of invasive species like this photo on the left here, we'll bring in brush hogs or forestry mowers and kind of really throw the kitchen sink at it. If you're working on a landscape with a lot of invasives, the more site prep you do, the better you're going to be in the long run. You're really going to thank yourselves in the out years when you're back maintaining. If you really did intensive site prep, you're just able to access the planting easier and the trees should be in better shape. I also want to mention that herbicide can be a helpful tool for managing invasives. We're fortunate in the mid-Atlantic to have very fertile soils and ideal growing conditions, and I think our multiflora rose, our bittersweet, our autumn olive, all of the host of invasives would agree with that. And herbicide is really a helpful tool to actually eradicate some of those invasives up front versus having to go back and cut vines year after year. We work on a lot of agricultural landscapes, and typically the area along the stream is the least productive in terms of crop production. So a lot of farmers have kind of left it to be pasture. Their cows, their horses are out in this area. So before doing any planting, we are fencing them out. This is the single most important practice when it comes to sediment reduction, sediment load on a stream. Fencing out the livestock who are just mowing down the vegetation along the banks, beating up the banks, putting a lot of weight and pressure and stress on the banks and the stream bottom itself. We'll fence them out, create a crossing to connect pastures if needed. And this isn't only for stream health, but also herd health. We've heard from a number of farmers that they know that there's nothing good in the cow. There's nothing in the cow that's good for the stream, and there's nothing in the stream that's good for the cow. So it's a reciprocal benefit there. And also for tree health. When we're planting these trees, we have enough wildlife stress to deal with. We don't need to add any more animals to the mix. So we don't allow any livestock in the plantings, so we pay for the fencing to keep them out. Now we're on to layout. Before planting any of our sites, we go out and flag everything so that the landowner knows where all of the plantings are going, and the contractors who are doing the planting can move through pretty quickly, and they're not having to make those decisions. A typical planting is 15 by 15 feet in rows and columns, kind of this grid layout that you see here. Some people like the grid. It's very orderly. It's very easy to maintain. Some people would rather it be more naturalistic. We can work within those bounds of layout preferences to an extent, but we really want to keep in mind the ease of maintenance and the access to the site. So we try to not plant anything much closer than 15 feet so that you can get 2 mower passes between each row. We're also keeping in mind the mature height of trees, again, depending on what you're planting around. And we're really prioritizing those long-lived overstory trees like the sycamores and the swamp white oaks along the stream bank and as close as we can get, because those are really the heavy hitters in terms of, you know, ecological benefits and long-lived benefits of buffers. And then if we're working along crop fields, for example, we'll kind of taper down in terms of tree size and have understory trees and shrubs out towards the edge of the buffer. Again, planning for that ease of maintenance. You will really thank yourself come the next year when you did not have a super crazy layout that's impossible to mow and just full of obstacles. We plant 20 to 30 different species on any given site, depending on how big the site is. And we aim for 70% trees, 30% shrubs to get that multi-layered approach. We have some fast-growing, early successional species in there, some slow-growing oaks that are going to hopefully outlive all of us. And we have some, multi-stem shrubs for pollinator benefit and just to get that multi-layered canopy. And as we were preparing this presentation, I was reminded by our director, Matt Earhart, that this level of diversity is very recent to the scene. Just 20 to 30 years ago, when our team was starting to plant buffers, we could only get our hands on 3 native species at a maximum, and one of those included green ash. Where do we think we stand with those plantings now? So being able to test out all of these species on buffers is a relatively new thing that we're kind of trying to hold ourselves back with so that we're not just throwing too many things at it. But we're really fortunate to work with some really great native plant nurseries in the Mid-Atlantic. We have a plethora of native plants at our disposal. And we're working with container seedlings. So 3 by 3 by 9 Anderson band pots. And they're cost effective, again, on that cost per acre basis. They grow really quickly because of that root to shoot ratio. They have 9 inches of root to about, a foot of stem, so that's a really good ratio that you want. So even within the first year of planting, the majority of the trees are 4 to 5 feet tall, even though they started at about a foot tall. Everything we plant goes into a 5-foot tree shelter. We have enough deer in this region that we're confident there's deer on every site that we plant, even if it seems like there's not a lot of forest cover around. We have been humbled too many times in the past. We don't love the amount of plastic that we're needing to put on the landscape, but it's a necessary evil because our priority is tree survival. We want the majority of what we plant to actually make it into the canopy 20, 30, 40, 50 years later. And tree shelters have been the way that we've found to get there. If you're working on a smaller scale, welded wire cages can be an option. They're a little bit more cumbersome. They're 2 to 3 times the cost. Again, if we're planting a 15 by 15 foot spacing, it's 194 stems an acre. So that cost adds up really quickly. You can use welded wire cages. Some people really hate the look of shelters, but we still put a little shelter in there for vole protection, which I'll talk about in a minute. But as long as your tree protection is at least 5 foot tall, some planter shelters are even 6 foot tall. 5 feet tall is what we found to be that sweet spot where it's no longer at that browse height. But deer seem to be evolving pretty quickly. They're eating species they didn't normally eat. They're reaching heights they didn't normally reach. So we'll see if 5-foot shelters are suiting us in the future. But back when we first started planting these buffers, we had pretty much no survival because we weren't protecting from deer, and the deer pressures have only gotten worse since. Every shelter comes with a bird net. So we, again, back in the early days of planting trees, we were finally starting to get good success using these shelters, but we were finding dead birds at the bottom of them. For whatever reason, birds would perch on the top, maybe get curious about insects that were down in the shelter. They would slip and fall in based on the slick plastic. And for whatever reason, there would be a dead bird and a dead tree inside a good amount of the shelters. So to prevent both of those scenarios, we put a bird net on every shelter unless the tree is already 4 feet tall, which is pretty irregular for what we're planting, but some silver maples will surprise you. And with that, we're, again, maintaining 300 to 450 acres a year. We're getting out to these sites about twice during the growing season. A lot can happen in that time. Trees grow really quickly. And we are making sure we're always using what we call the center hole method. So we're pulling that bird net down so that there's about an opening the size of a quarter in the middle, so that if we're not able to get out to the site as soon as we'd want to, we know that our stems aren't getting tangled up, which is what was happening when we were using kind of more of a tassel method beforehand. Again, we ask a lot of very specific questions, as you can see, working at a research institute, like what size hole should we have when we're pulling the bird net down to? In my mind, deer are public enemy number 1, and voles are public enemy number 2 of buffers and other rodents. But voles inhabit these meadowy areas with tall grasses and herbaceous plants, and they like to keep it a meadow. They are very effective at what they do, and anything woody on the site, they will chew the bark at the base of it and basically just cut its head off. And when we were starting to get good survival by protecting from deer, we were then humbled by rodents. So, managing vole protection has evolved over the years. Mowing is still one of our best methods to keep that habitat low, and then using what we call clean culture by keeping the area around the shelter free of vegetation, grasses, weeds. That used to look like spraying herbicide rings. We'd spray a 3-foot diameter herbicide ring around every shelter twice a year for the first 3 years. It's intensive. It uses a good amount of chemicals. There's a lot of, environmental and worker exposure there that we were trying to get away from. And if we're working with organic operations, they wouldn't allow that practice anyways. So we have since moved to a practice that we have borrowed from the orchard nursery, the orchard trade, which is using 2A modified stone around the base of each tree. So this is stone that has coarser bits of gravel and then some finer, almost sandier bits of gravel in there. And it kind of solidifies into this solid mound around the shelter base, keeping the shelter in place. And so far, we've seen that it's been really good at protecting from voles getting into the shelters and nesting there. It's also more cost-effective than herbicide treatment because you're only applying it once at the time of planting. So you're kind of throwing the kitchen sink at the buffer at the time of planting and easing up on the maintenance later on, but still keeping at the maintenance. Speaking of maintenance, once planting's finished, we shift gears into maintaining those 350 to 450 acres. And again, working at that scale, this is kind of, I'd say, the baseline of what we know to be the recipe for a successful buffer. If you have resources, if you're working at a smaller scale and can be out there doing more maintenance, the trees will thank you. But for us, this looks like mowing 2 to 3 times a year from kind of May through September, and especially in September, October, doing one last mow so that the grass is nice and low. So again, those voles don't nest inside of our tree shelters. That kind of covers the vegetation on the outside of the trees. On the inside of the tree shelters, we're applying a granular pre-emergent twice a year for the first 2 years. This is preventing weed seeds that the birds so graciously deposit from germinating and competing with the trees in our shelter. Too often we would come back to a site and see from a distance, you see a lot of green above the shelters, and then up close you see it's bittersweet, it's multiflora rose, it's mulberry, it's something that we didn't plant and we don't necessarily want on the site. So far the pre-emergent has been a good way to manage that. We also get out with typically interns or contractors to do stake and shelter maintenance, especially after storms, heavy winds, heavy rains, about 4 times a year, about once a season. And we're also looking at those bird nets, seeing where the trees are in the shelter and removing them, getting that plastic off the site, and reducing any tangling that could still happen. Later in the season, we're doing survival counts and marking dead shelters that will need replanting. For us, our threshold is 70% total survival at the end of those 3 years. I think a lot of us on our team would agree that that's even lower than we'd want it, knowing that there's still going to be mortality in years 4, 5, 6, 7. But 70% is where we're at. The first 3 years are really the most intensive maintenance, and then years 4 through 7, this is when we transition it back to the landowner. It's when our grant funding doesn't allow us to keep maintaining a site, and we really have to move on to maintaining other buffers. And so we always recommend to stop mowing at year 4 for most cases. If there's really bad invasive pressure, continual mowing would probably be a benefit. And leaving the leaves to start forming those forested soils, kind of reducing that vegetative pressure, allowing the shade to take in and do what it does. We still want to leave the tree shelters on at this point. You can cut them open, but they are self-perforated, so they're self-removing and they're not going to strangle the tree if all goes well. Doing some invasive removal as needed. Again, we're not getting away from invasives in this region no matter how much site prep you throw at it. And also replanting in open areas with fast-growing trees. When you reduce the mowing, hopefully there's natural regeneration that starts to happen, so we try to encourage protecting those seedlings before deer or other herbivores have a chance to mow them down, because those are free trees. Just to illustrate why we leave the shelters on for so long, they are very effective at what they do. They're perforated and they split from the bottom up, and they kind of form this little jacket on the tree, 6, 7 years later. And I think a lot of people would look at it, myself included, when I first started working in buffers, look at it and say, I think that tree's old enough, it's 2 to 3 inches in diameter. I think we're ready to take off the tree shelters. But we, and Calen's going to talk about this more, we've been humbled too many times. The deer pressure in this area is too inconsistent and it can really wreak havoc. And it's a shame to lose so many trees 7 years after planting them, after doing all of this intensive maintenance. We've seen just deer demolish, particularly red maples, even a week or two after removing shelters, so really keeping them on is a key to success. And once you have the canopy above the shelters, it does feel less like a field of plastic, which is my weak attempt at selling tree shelters. And then in years 10 and up, you know, this is kind of when I think it starts to actually feel like a forest and less like a planting. Those, you know, rows and columns of plantings kind of soften as things grow in and maybe some things die off and you plant it elsewhere. And we really try to just encourage people to get out and enjoy the planting and enjoy, you know, the recreational benefits, hunting, bird watching. You know, our team made an effort this past season to go out onto some of the older buffers that we've planted that were 15, 20, 25 years old, which is what's pictured here. And we saw a very consistent trend that the most successful buffers were the ones that had very engaged landowners that were interested in the project and really excited to see the progress. And while they were spending time in their buffer, they were noticing the invasives coming in. They were cutting the vines, and they were still doing some of that maintenance, which is why this looks probably different than the forested systems that we see outside of our back door. Similar to the forest that we see outside of our back door, we also saw a huge lack of understory, natively seeding in or planted. At the time of these plantings, shrubs typically weren't included, so that makes sense, but it was also heartening to see that, you know, no shrubs seeded in. So keeping in mind that, you know, shade-tolerant species like spicebush later on could really help this be more of a multi-layered planting. And again, looking for natural regeneration and protecting those free trees. With this in mind, again, our job is to ask questions, and this, you know, kind of quick how-to guide, how to build a buffer, is by no means the final answer. Not to spoil Calen's talk, but we're still asking a lot of these questions and still putting all of our practices under the microscope, putting them to the test, and seeing if there's a better, more efficient, more cost-effective way to achieve these plantings. And with that, I will turn it over to Calen.
Okay. Can everybody hear me all right? Beautiful. All right, so I'm the data guy. I do bar graphs and I look at trees for a living, so hopefully I don't bore you all to death, but there's a lot of good information in here. So just to kind of give reference into what we're looking at and how Heather has provided the information in the context of what we do, we kind of start off with trying to tackle like three big problems right off the bat in any sort of scenario and any sort of planting context. We have an animal problem, we have a competition problem, which is usually plants, and then the last bullet is kind of like this, so what else can we do to better our projects? Because now that we tackled the proverbial elephant in the room, what minute details are we overlooking, right? Is there anything that we can improve upon? So let's talk about animals first. And I have just a hair bit of difference here. I consider meadow voles problematic species number one. Given the context, I mean, there was a huge buffer blitz in the late 90s, early 2000s. And this was, by the regard that I hear, a plant and forget type of scenario. This meadow vole is probably the number one reason why those early projects failed. For the uninitiated, if you've never seen a meadow vole in person, they are just basically a sausage link with little legs that like to scurry right underneath that duff layer. They really like these wetland soils, and they prefer grasses more than they do shrubs and kind of that really woody understory. So yeah, you provide a nice little greenhouse that's warm and safe and away from predators because everything eats these little things. They move in quick. So the early question is, well, how do we mitigate the damage from these little critters? And, well, let's ask the people who have been doing it for close to a century, the orchardists. They first introduced us to a practice called clean culture. In essence, it's keeping the base of your tree weed-free and clean and open as much as possible. Early on, we accomplished this with herbicide specifically. Because we're using a plastic tree shelter, we have a barrier that we could sink into the soil a little bit. We can spray a 3-foot or 6-foot diameter ring around the base of each shelter and create this nice open weed-free area. And here's kind of what we saw even in our early plantings. The herbicide helps. This clean culture concept helps. But there are some problems when you start talking about herbicide. One of the big ones is you have to apply twice a year, so it's weed-free at the base of your shelter going into the fall when voles are not as active. So to combat this overwhelming need to apply herbicide constantly, and again, frame of reference, we're doing these projects at scale, maintaining somewhere between 300 to 400 acres a year. We're planting at 200 stems an acre, so y'all do the math on how many tens of thousands of trees we have to maintain. So when we went back to the orchardists and said, hey, is there anything that we can do that doesn't involve herbicide twice a year? They pointed us into the direction of physical barriers. Now, between 2A modified stone mulch or a physical wire mesh wrapping that they use at the base of their trees, we could only really afford to do at scale stone mulch. This is the kind of first trial to see what the validity of a physical barrier would be. We have a plastic tree wrap that would go on the inside of the shelter around the base of the seedling. We had railroad ballast stone, which was just basically clean 2-inch and above stone, and we had this 2A modified, so big stone and all the filings packed in. What we had found out over our trials where we implemented this, the plastic wrap ended up girdling a lot of our trees in the same regard as the meadow voles did, and the railroad ballast left too many void spaces for these meadow voles to kind of work their way through and get at these shelters. So unfortunately, we had to disregard both the plastic wrap and the railroad ballast and move forward with the promising scenario, which was this 2A modified. So let's talk about the first couple of trials where we put this herbicide knowledge that we had straight up against stone mulch. In these first couple of trials, we didn't know how much stone mulch was going to be effective. We were sincerely hoping that the smaller option was going to be viable. And it's fairly interesting. So, frame of reference. I love doing plantings with volunteers just for the camaraderie, and it's a great atmosphere to get a whole bunch of people out and just do these projects and have a good time. If you really want to test your volunteers, do a planting for about 2.5 hours and then say, hey, we need to put stone mulch at the base of all these trees you guys just spent planting. And here's the other numbers. That 20-inch diameter stone, that's 40 pounds of stone per tree. The 12-inch is 20 pounds. We did this initially by wheelbarrow and 5-gallon buckets. So my rotator cuffs still twinge thinking about these early ones. But now we're looking at this from a scaling perspective. You know, we plant a lot of our projects with contractors. Can we do this at scale, and can we do it efficiently? The answer is yes, because thankfully they have machinery, so it makes life way easier. So, getting that precursor out of the way, let's look at the side-by-side. What we had found out is our survivorship is right on par. And thankfully, the 20 pounds of stone is almost directly on par with the herbicide. Awesome. Still didn't lighten the load at the time of the applying, but it's good to know that this physical barrier works and we can employ it at scale. Now, the part that we look at as a nonprofit is the cost effectiveness. So here you go, side by side between what it costs to do herbicide and what it costs to do stone. So doing this stone right up front is way in our interest. One of the big proponents that Heather hit on is, you know, we like the look of this stone because it's additional protection in the out years after we're done with maintenance. There's still a physical barrier wherein when you stop applying herbicide, usually the first thing that comes back into those open spaces are invasives, which can be highly problematic. So great, we took care of the meadow vole problem. That is one animal that we tackled. Let's move to the other one. And when we start talking about deer, it usually comes in the form of tree shelters. First and foremost, this is the one thing that we use at scale, that we just want to ensure that our little saplings have as much protection as possible. The question we get commonly is, well, can we use something else other than a tree shelter? Sure, but I would highly recommend using something. This graphic here, published in 2002, put unsheltered trees side by side with sheltered trees. And this is year 4 data, so you can take that account for yourself. Use something, don't just plant and leave. So over the years, we have gotten a lot of kind of test samples of different tree sheltering methods or different tree shelters. And as long as we have the space, we want to test them. So the big thing here is in photo number 4. Photo number 4, all the way to your left, is an unvented tube. These are the tubes we started with, and these are the ones that we started at with scale. And we kind of ran into some problems that I'm going to talk about here in just a bit. But more often than not, we're looking at ventilation to try to help mitigate some of the problems that we have. So the biggest problem was sometimes we had trees in this part of southeastern PA that grew a little bit too fast for their health. And we ended up with this syndrome that we just called the flopping syndrome. Basically, these shelters are a micro greenhouse. A lot of these stems and a lot of these trees want to push up as fast as possible. And in the case of this poor river birch here, when it got to the top of that shelter, it didn't want to equally spread out or grow caliper as it's developing its canopy. It just put all of its energy in producing a canopy while no support in underneath it. So we were hoping that ventilated tubes would be a solution to kind of slowing these trees down and getting a better and more kind of average growth rate instead of everything all at once. So we put some ventilated tubes side by side with some unvented tubes, and here's kind of the problem. We really didn't find a significant difference that said, well, ventilated tubes are a little bit better than unvented. And when we trialed this again, going just all pure ventilated tubes, yeah, we still didn't exactly find a whole lot of significance. So if you're asking the question, well, what about the growth rates? Because maybe not just survivorship, you should be able to see a change in growth rate between a vented and unventilated tube? No, no you don't. Unfortunately, this corner of the state, everything just grows way too fast. Between the amount of degree days that we have for avid plant growth and the milder temperatures in the winter, these things are growing 365. So doesn't matter really what you use down through here, it all equals out. So now that we protected our tree from buck rub, let's look at the next aspect and probably the next costly part of maintaining a buffer, which is mowing. Our prescription at this point is to mow 2 times a year. Most of the areas that we maintain are not nice turf grasses and manicured lawns. These are kind of the woolly areas of old pastures, old crop fields with a whole host of different problems. What we had found through our studies is that mowing twice a year is enough to get these trees jump-started to compete with everything else around them. But now that we've introduced stone, a physical barrier at the bottom of the tube, we were trying to see, can we stretch out this mowing? There's a physical barrier. We don't have to worry about vole damage anymore, hopefully. So maybe we can look at this. Unfortunately, no, we still got to mow. Our first trials basically said when we started to taper or we didn't mow at all, we lost quite a few trees, and for a multitude of reasons. We couldn't exactly narrow it down to one factor over the other. It was just a pretty stark description that the areas that we mowed had better survivorship than the areas we didn't. And when we ran this trial again on a 20-acre floodplain that has kind of even keel conditions and didn't have wet corners, and we could afford to have kind of this homogeneous ecotype, we still found the same problem. As a matter of fact, the areas that we didn't mow, we had to take out of our survey because anytime we get below 70% survivorship, one of our big proponents as a program for Stroud is we go into replant. And to drop from 97% to 56% in a year, that is terrifying. So yeah, we are still mowing. We're still advocating for mowing. Maybe in the future we figure something else out, but for right now, we still highly recommend it. Okay, so competition outside of the tube, check, great. Now let's look at the problems inside the tube. As Heather mentioned, there have been times that we show up to a site and unfortunately you see the photo on your left. It is completely wrapped up with Oriental bittersweet. If there is a tree in that mix, it's probably either permanently disfigured or completely dead from lack of sunlight. Again, these problems get into our tube in a nice little fertilizer packet, mainly from songbirds, and we have to try to mitigate this stuff before it happens. As of right now, we were using a pre-emergent called Snapshot. The kind of over-the-counter equivalent to Snapshot is called Preen. You can find it in almost every big box store possible. The long and short is to avoid these problems that we have with these invasive seeds. We're hitting them at time of germination. So through our studies, we had figured out that we can apply this Snapshot twice a year, typically in mid-March and again in June, and keep this tree tube weed-free all the way through the fall, when it's too late for those seeds to germinate at a appropriate level. Now, as of right now, the alternative is hand weeding each individual tube. Again, I already gave you the statistics on how many acres and how many trees we're looking at per year. Right now, Snapshot is the most effective course to ensure that we have as little competition inside of that tube as possible. Now, here is kind of our frame of reference for shelter removal and mitigating deer damage. In our trials, we tested what the initial buffer handbooks had said. The initial buffer handbooks that were given out at scale kind of in the early 2000s said you can remove these tree shelters when your tree reaches 2 inches caliper at the top of your shelter. And we said, okay, let's test it. So we did 3 different scenarios, one where we fully removed, just like the code book said, one where we just split the tube top to bottom, left it in place, and another one where we never touched the shelter at all. We just kind of let it be. Here's what we found. Now, the ones where we had removed those shelters fully, that 47% in the study that got buck rubbed, the majority of those died. And when you're talking about removing these tree shelters at roughly 3 years, 4 years into your buffer's lifespan, that's a tough loss to take. That is a lot of time, that is a lot of energy invested into your tree to get ruined in one winter. Even when we fully split the tube, we still had buck damage. Sometimes the tube blew off in the wind. Other times it was just, we had one buck that apparently just really wanted to rub that tree specifically. So we kind of came to the conclusion of leave the tube in place. Now, a little bit of extra information. The photo that Heather had shown you about the zipper cut, where it's a cut at the bottom of the shelter, cut at the top of the shelter, and leaving the middle intact. There are some species that do not respond well to having water and leaves being held tightly against their bark. If you run into these scenarios, and typically it's along the locust family, we advocate that you do this zipper cut to allow water to drain out. Otherwise, the perforated seam is good enough that, and will be weak enough by the time that tree grows into the diameter that it will bust it out itself. Okay, so unfortunately, this is going to be very fast because this is the disclaimer that I have. Our time frame to learn anything about these trees is usually 3 to 4 years before we get actual good data that can be inferred whether a practice is working or not. Everything from here on out is in its infancy, meaning this is 1 trial or 2 trials that have just hit that 4-year mark. So you gotta love working on tree time frame, right? But this is kind of the refinement process. These are the little micro details. Can there be 1 or 2 things that we switch when we go to a site that can ensure our success long term? So the first part is we got approached by Plantra. Plantra is a US-based tree tube manufacturing company. One of their hallmarks is they like to use a fiberglass stake as part of their install. But they came to us with kind of this weird notion of, why don't we take our tube, which was basically a solid rectangle, and cut these little archways open both in the top and the bottom. So that way when you install it, doesn't matter which way the tube is up or down, you still have this little arch that sits at the bottom. The thought process is that that little archway, even though it's open to meadow voles, it's also open to foxes and anything else that'll eat those meadow voles. So when we installed this, the precursor is we put this side by side with our typical standard, which is tree tube 2A modified stone and mowing twice a year, next to this, which did not get stone because we needed to leave that bottom open, but still mowed it twice a year. And here's kind of where we're at early on. Now, the numbers that I kind of look at in year 3, this is a little, this is kind of interesting. You could expect that there was some sort of damage at some point. You're leaving a tree shelter in viable habitat to its own devices. I think there is a calculation where basically you have to adjust for some losses. But to have 77% survivorship when it's just the tube and mowing twice a year, that's interesting. But again, this is really in its infancy, and we need to replicate this before we talk about that any further. Now, the next part is reed canary grass is it's one of the more problematic species that we deal with day to day. It's an invasive grass that really loves wetland soils. There was a notion that you kind of have to do something ahead of time to knock back the grass mat in order to have your trees grow up through it. So in this study, we treated with herbicide at different rings, a 6-foot ring and a 3-foot ring, to see if that even mattered. And so far in this study, it doesn't. We still have survivorship whether we're just planting straight through that grass mat and applying stone at the base of it, or we're doing a pre-treatment before we put the stone down, which is interesting. Again, we need to replicate that before we move any further. Now, one of the big things of trying to hit our diversity numbers when we go to a planting is the inclusion of multi-stem shrubs. Multi-stem shrubs can be problematic because when you have something that really just wants to splay out more than it wants to grow upright, and you force that little thing in a 5-foot tube and say, go up, sometimes you get some weird effects. So we did a whole host of different trials. We did block caging, where it is a 2x3 rectangle and fenced out the entire thing, put them in little shelters to see if that mattered. We put them in clusters to try to see if we can't do something when we release them that maybe the interior plants never get hit by deer and the other ones just take the brunt of deer focus. And we did individual cages to try to see what the growth patterns would be like. What we had found out is basically survivorship's just scattered across the board. The individual shelters probably have the most promise, but the problem is at the moment is that welded wire is pretty expensive and kind of unruly to deal with. So unfortunately, we can't do this at scale just yet, but again, this is very early on. We need to do some replicates. So this is basically, we have some areas that are prone to heavy flooding. We want to see if there's management strategies around that. If we could get away with doing larger stock sizes, how effective are fiberglass in full flood, and how does our standard practice hold up? So the large stock, our definition of large stock is 5 to 7 gallon container trees. They can be anywhere from about 1/2 inch to maybe 3/4 of an inch in diameter. When we installed it, we got a very friendly reminder from the deer that, yeah, spiral wraps don't work. You better use something a little bit sturdier than that. And the last bit is kind of where we're heading towards next. So I had mentioned for now, we're looking at Snapshot as being kind of the precursor of how we deal with weeds inside of the tube. We're looking at non-chemical options, 2 of them being the rice hulls that you see pictured here, which are just a byproduct of the rice industry. They're nice that they're sterile, so weed seeds have a really hard time growing on top of them. We just installed those plots this past fall, so really early on. The next parts are basically, let's see how effective fiberglass stakes are. Driver for this is kind of twofold. We used to rely on treated oak stakes as our support method for our trees. Unfortunately, the prices to ship those has gotten a little high for our taste. And we found a fairly good alternative in a fiberglass stake. These ones are 3/8-inch diameter by 6 foot long, so they kind of mirror exactly what our 5-foot treated oak stake would do. But we're also looking at different ways of kind of making sure that those shelters stay on the tube. Pictured in the middle is just a 1/2-inch hose clamp that was tightened down. And we're also looking at different thicknesses between 3/8 and 1/2-inch fiberglass stakes, seeing if that makes a difference, seeing if length makes a difference, and seeing if we can refine anything there. Last bit is the picture that's all the way to your left. Plantra also came out with a tube that has these kind of like weird little, they kind of like cut into the top of their tube. The idea is that this is a replacement for using a bird net. These little these little fingers essentially are really flexible, and the thought is that birds don't want to perch on anything that's way too flexible. So we're trying to see if we can move away from bird nets as well, and again, really early on in any of those. But that's my spiel, and we'll open it up to questions. Yes?
Has there been any consideration, or is it outside the realm of possibility to use a tree guard that's reusable?
There has. The unfortunate part is we just haven't found it yet. The closest we could probably say is welded wire cage. It's just not feasible right now with both the price of the material itself and the cost of the labor to make those individual shelters.
And I would add to that the time and labor and storage of retrieving and reusing them adds another layer of complexity. If you're, say, removing 6,000 tree shelters to put onto new sites, it's a lot of material schlepping. And yeah, what Calen was saying, with current designs of tree shelters, we're really leaving them on as long as we can so they break open. So I haven't seen anything that seems like it could easily be reused. Yeah. Interesting thought, though.
Yeah.
There's a design that an orchard grower had shown me up in New York, where they took a landscape fabric, sewed two ends of it together, coiled up a wire mesh cage, placed that on the outside of the cage, and let the cage expand, and that held the landscape fabric in place. They'd also take down maybe an inch or two around the base to set that in so there wasn't a way for the bolts to get underneath, but it had great success with it. On a smaller scale, you're doing things on a large scale, so we have price points. But what are your suggestions for smaller scale agricultural abatements for orchards that don't have as much of a price point target as you have on large scale?
For bolt protection or just in general?
For tree protection, either poles or native predators.
I would say if you have all the money in the world, do a deer fence, if you can.
Yeah, all the way around it.
Yeah, right.
That's the way to go.
Yeah, I don't know. Oh, that's the most expensive option.
Yeah.
Unfortunately, none of our landowners want to install that themselves beforehand.
Unfortunately. Yes.
Have you found that the stone mulch just has a tendency to maybe wash away if it's placed around a tube along a stream bank that floods several times a year?
Yeah. So
Is there any alternative?
it also depends on site conditions. That stone sticks around for quite a while, and it really does take a hard scour to move it off. We have had cases in the past where we've had a freak flood come through, 100-year flood that did scour off, and we just try to replace it as soon as possible. As for a more permanent, in a high flooding, high velocity environment, I don't exactly have a good alternative outside of, say, herbicide as a methodology to keep it weed-free around the tube.
Or if you can keep it more mowed. Like there's
Correct.
a few instances where landowners want to keep it mowed to a grass lawn and they're willing to do that mowing. In that case, we don't necessarily need to use stone mulch. Like it's kind of like planting in a park. There's not a lot of rodent influence there. But yeah, it depends on access. If it's a soggy area, you might not be able to get in with mowers.
Yes.
So I'm with a small all-volunteer land trust, so our economics are very different. But one thing we found is that it makes sense to replant failures, so maybe we can tolerate a higher failure rate. So that's kind of one thing. Second is that those bollgards seem to be working, at least in the first years, those small kind of black rat things. And finally, any comment on beaver? We've had really significant beaver
Yeah, unfortunately with beaver, that is a brand new can of worms, and unfortunately we like to be involved on the site as long as possible, just because for one, again, statistics on how many trees we're planting and maintaining, that's an awful lot of plastic to ask the landowners to maintain. But a lot of our projects just aren't at that age yet where beaver would be impactful on those sizes yet. So maybe in the future we revisit this problem, but for now, I don't have anything, unfortunately. Yes?
Years ago, I heard Ernest Sweeney say that the deer didn't like to jump into confined spaces, and I wondered if there was any more research or findings on that, or if that just not working.
So, yeah, in those references studies, we had done a few plots of varying sizes from anywhere up to, from a quarter acre all the way out to about 3 acres. What we did was we stole a tidbit from horse trainers and horse farmers. If you want to keep your stallion inside of his fence, you do 2 short fences, but space the fence about 10 foot apart. We took that practice, got 4 foot high welded wire fence, did the same thing. Did the exclosure with 2 fences spaced 10 foot apart. We had found that in the smaller confined spaces, those had worked really, really well, that the deer didn't want to get into the middle of it. When you got up above like an acre, acre and a half, deer still found their way in. And also the cost of not only installing the welded wire fence, but also maintaining it in a floodplain, just unfortunately didn't seem viable for the work that we do. If we had an upland planting, we could probably revisit that, but currently streamside, it's just not feasible.
Is there a way that you ensure genetic variation between the plants that you plant, or is that something that the nursery figures out? I'm just curious about that.
Yeah, we source the majority of our stems from Octorara Native Plant Nursery. We're not sponsored, but Jim, if you're in the room, you can let me talk. And they germinate, the majority of their plants are from seed germination, so there is genetic diversity in there. I think willows are the only ones that they use basically little live stakes for. Our mentality is kind of, throw as many species as you can reasonably at a site. What survives, survives. It kind of evolves over time. But we don't do cultivars, it's all straight species, so there's genetic diversity in that, and knowing that it's majority seed sources from local areas. We feel pretty confident, and it's good quality stock.
Yes.
You said, you talked about one of the things that you do beforehand is check the soil. How often have you had to do a soil remediation in your plantings?
I don't believe I've ever done a soil remediation. It's just one of our precursors before we plant a site is we just do a web soil survey, make sure we have an understanding of what the soil textures look like, what the drainages look like, and then if we need to take an extra step to shade certain species towards wetter areas or shade certain species towards drier areas and sunlight availability, we do that at the layout phase. When we're physically putting pin flags in the ground where plants need to go. Yes?
So for soil classification, you just do like a desktop review. Do you field verify, like seasonal high saturation, figure out your boundaries, or you want to plant your wetter species, or like your transitional species?
Yeah. We do plenty of field walks long before trees ever show up on a site and long before contractors show to do the site prep. So we have understandings to verify what web soil survey is telling us, especially when it comes to hydrology, because nothing's worse than getting a standing water or vernal pool and trying to put a species in that.
To that point, we don't verify with an actual soil sample. We're not sending that out for testing. And in the 30 years we've been planting buffers, the soil we're working in is very fertile. The trees have a pH tolerance range. We've seen really good success, so I think we haven't gotten to the point where we see a need for that verification via a soil sample. Things grow very happily in the floodplain.
Yes.
Do you let the wasp nests in the tubes or remove them?
Ask our interns.
Yeah. We tend to leave them in. Maybe we knock them out during the winter, but we're fortunate in that wasps are a problem for us. They get killed off in the winter, but we don't have to worry about an animal coming in and ruining our tree tubes and ruining the tree. If we were talking north central PA, that's a completely different story and a completely set of circumstances that you have to account for. But we just kind of tend to tiptoe away and let them be for a bit. So.
An unfortunate reality of tree shelters as well.
Yes.
You know, how many times I like to maintain the tube,
Yeah.
stick my head in.
Yeah.
Hey, sorry.
They're looking right back at you.
Yeah.
Yeah.
Yes.
How are you determining what different varieties of trees you plant in different areas of the property? One thing I did want to bring up is just the uses of Riparian buffer zones in the farm tillage and fertilized fields and keeping that fertilizers behind. Do you have recommendations of specific types of trees that will absorb phosphates or absorb nitrogens along waterways to keep those waterways clear? In particular, if they're running into lakes where there'll be algae blooms.
I don't know of species particularly handling that better than other species. We approach it at the landscape scale, kind of saying, okay, if we reforest this area and recreate a vegetative buffer, it's going to take a while for it to act as a filter and slow down the runoff from the fields before it reaches the stream. But kind of looking at it on a wider approach versus species by species, I'm not aware of like if a honey locust here versus an elderberry there is going to have a different uptake of phosphates. I'm not sure. And ultimately, if sometimes we're converting crop field to buffer, so again, getting that very intensively managed area back from the stream, fencing up the panel, I think does more than if you're worrying about species. Yeah. Unfortunately, we are out of time. We've gone a little bit over as well. So I recommend if you have any other questions, reach out to the presenters individually.